In this lesson, we're going to talk about the multi-tenant data center functionality. Obviously, with multi-tenancy, what are we concerned about? We're concerned about multiple customers utilizing a single data center environment, right? Trying to share compute resources, have really these different layers of abstraction, unified data center resources, et cetera, right? So in this lesson, we're going to talk about the multi-tenant data center. We're going to describe how we separate those tenants from each other, how we can use VRF-Lite to get that layer 3 separation, looking at virtual device context to provide that separation as well. And then we'll take a look at kind of an overall example, and then we'll look at micro-segmentation again with different overlay networks. We did a brief introduction to that concept in the last lesson. We were talking about overlay networks, but we're going to get into that in a little bit more detail in this particular lesson here. It's not a long lesson, it's a relatively short one, but it does have some decent information, okay? We know that virtualization of compute and storage resources it gives us the ability to share resources across the data center, but not only within an organization, outside of the organization as well, right? So sharing of these physical resources across different entities that are not necessarily directly related to each other obviously has some security, or brings up some security concerns, right? In addition, we have to concern ourselves with oversubscription or overutilization. So we have to have logical isolation of these virtual resources, and that's what we see in this multi-tenancy environment. A tenant, by definition, is just a user community with some level of shared affinity, I guess you could say, right? The tenant might be a customer in an IaaS cloud, right? Information as a service cloud. Sorry? Infrastructure. Yeah. Did I say? Information. Internet. Infrastructure. Sorry. It's early in the morning. I apologize. Infrastructure as a service, or it could be other applications like SaaS and so on. Within an enterprise, a tenant may be a specific business unit within an organization, right? It could be a department within a company. It could be a work group of users. It doesn't necessarily have to be a completely different entity, but we still have security concerns about cross-pollination of information and the ability to hide that information from these different work groups or departments or whatnot. When data center hosts in a multi-tiered application want to access, a tenant could even be a single application layer, maybe a web application or a database application layer. So don't just assume that multi-tenancy means multiple enterprises accessing the same resources. It can be multiple levels of this multi-tenancy. Deploying tenants in the shared common infrastructure, because it's infrastructure as a service, right? Not information as a service, although that sounds pretty cool, right? Infrastructure, it's going to optimize resource utilization, of course. It's going to lower our costs, but it does require that you design this multi-tenancy environment with security in mind. We want to have that tenant separation. We want to make sure we have end-to-end path isolation to meet whatever tenant requirements we have. So that's what we're going to talk about now, right? The multi-tenant data center separates resources into multiple silos, right? Multiple resources. It could be network resources, compute resources, storage, application, etc., right? That segmentation, that network separation is achieved with path isolation techniques, right? And the goal here is to logically divide our shared infrastructure into multiple per tenant virtual networks. We can see a representation of some of those path isolation techniques on the slide here, right? We can do this in a hierarchical fashion. For example, we can create this layer 3 network separation. The layer 3 network separation is depicted right here, right? This is typically done at the core, or it's done at the aggregation layer. We use VRF-Lite. What VRF-Lite allows us to do is implement per tenant isolation at layer 3 by having separate dedicated per tenant routing and forwarding tables, which ensures or makes sure that no inter-tenant traffic within the data center is going to be allowed. I mean, it could be, right? We could have explicit configurations that allow that inter-tenant communication if it's necessary, but the general rule is that we're going to disallow that by default, right? We can also create this layer 2 separation at the access layer, or at least at the virtual access layer. And that's a very simple concept, right? We use VLANs to provide that isolation, and we identify different tenant traffic across the layer 2 domain, and then across shared links through the infrastructure, we can pass VLANs using different trunking methods or whatnot. So that isolation is relatively simple. What about compute resources and network service resources on our physical appliances, right? We can create these virtual contexts, right? We have service modules or service components that we're providing services for. So we can create contexts, we can create zones that create this virtual security environment. We can do load balancing, we can do NAT, we can do SSL, we can offload services and applications in a unique per tenant policy. We could do that even at the VLAN level, right? And that's going to give us that granularity that's required to service these customers. We can have dedicated virtual appliances that are providing per tenant unique services within the compute layer of the infrastructure, right? We get that virtual machine level of granularity as well. The compute piece is fairly simple to virtualize, isn't it? Because we can have these different virtual machines for each of our tenants. So let's take a look at kind of each one of these components individually, and I'll try to give you a little bit more detail on each one of these, right? We know that tenant separation at layer 2, pretty easy to facilitate. We're going to just simply use VLANs. And VLANs, are something that you guys have dealt with constantly in the past, and of course a VLAN is just a VLAN. But at layer 3, we can't use VLANs. We have to have separate routing domains and separate routing instances. So we're going to use VRFs to achieve that separation, okay? We know what basically a VRF is from our discussion about MPLS. It's a virtual route forwarding instance, right? It's a technology that allows a router to hold multiple independent and even maybe duplicate routing tables, right? Where I might have even the same address space in each VRF. Does that make sense? All right. And then we take our interfaces and we assign different interfaces to different VRFs, and that's what's going to provide that separation. There's another benefit, though, of separating the routing and forwarding instances, and that benefit comes in the idea that we can have overlapping address space. one tenant or one department or one unit, or whatever you call it, can have the same address space as another, right? In a public cloud, this is a very common thing because obviously the tenants are working independently of each other. They don't know if they're using the same RFC 1918 address space or not. Mergers is another example of this, where I might have mergers or acquisitions involving IP address transitions in our private enterprise, where I buy a company or I acquire a company and they happen to be using the same address space that we're using, right? In the diagram, traffic that ingresses the core switch through the interface assigned to VRF-A is destined for the 192.168.0.100 subnet, all right? Now, the core switch performs a lookup in the VRF-A routing table, and then it's going to forward the traffic to the aggregation switch through the layer 3 interface that's assigned to VRF-A, all right? And by the way, that layer 3 interface can be a physical interface. It can be an SPI that's tied to a particular VLAN, okay? The aggregation switch receives the traffic through that layer 3 interface that's assigned to VRF-A. It does a lookup in the VRF-A routing table, and then it forwards the traffic to the VLAN 1 SPI, right? And that's what we're seeing depicted in the diagram here. Traffic gets sent through the VLAN 1 SPI to the destination server. It's a pretty simple thing to understand, right? We know that VRFs are commonly used to service in service provider networks, specifically with MPLS, because we saw that in the previous lessons when we were talking about separating customers' networks in an MPLS environment, okay? So the VRFs in that environment are going to provide that forwarding isolation, and then MPLS provides traffic isolation, etc. But we can use VRFs without MPLS. There's lots of scenarios where VRFs get employed without the use of MPLS. Anytime we want to provide any kind of traffic isolation at layer 3, we do a per VRF assigned connection. It could be with IPVPNs, or it could be outside of IPVPNs, all right? Essentially, the term VRF-Lite comes directly from the fact that we're using VRFs without MPLS. That's the only difference, right? It's a term that Cisco coined to identify the use of VRFs without MPLS, okay? Another component that was introduced, well, it's been around for quite some time, particularly in routing and firewall instances, and essentially a VRF even kind of qualifies for this, is a virtual device context, right? But the Cisco Nexus line of switches introduced the full true support of what we call VDCs, all right? A VDC allows switches to be virtualized at the physical device level. And what happens is each configured VDC looks like or acts like a unique device, all right? This is going to allow us to further expand that tenant separation, not just on the data and control planes, but also on the management plane. So customers can manage their own switch, well, virtual switch, I guess, in this case, okay? So a VDC actually runs as a separate logical entity within the switch itself. It maintains its own unique set of running software processes. It has its own configuration, and it's managed by a separate administrator. All right. So it's going to have its own unique independent set of VLANs. You're going to have your own unique independent set of VRFs. Physical ports can be assigned to a specific VDC, so you can tie physical interfaces to the I mean, obviously you're going to have some physical connectivity at some point, right? So we can assign physical interfaces to a specific VDC, giving us that data plane functionality, but tying it to that virtual switch. So it kind of ties in that hardware data plane, and it makes that hardware data plane, excuse me, virtual as well. So with every VDC, or within each VDC, we have a separate management domain that we can use to manage the VDC itself, even allowing the management plane to be virtualized, meaning that each tenant or each customer or whatever you want to call it has the ability then to manage their own environment. Okay? All right. So let's wrap up this this lesson here by taking a look at a basic case study. All right? So if we look at the bullet points here, we want to design a hybrid multi-tenant data center that meets the requirements of our enterprise internal applications and our e-commerce applications. And we see that listed there. We want to, you know, operate our internal services and our e-commerce services. What are the other requirements? The data center has to host the enterprise's internal servers, right? And that's what's going to be our internal services. Email, collaboration, things that are going to run on dedicated servers within the environment. We also want to host our e-commerce applications, which are, well, e-commerce kind of gives you the impression that these are going to be services that are accessed from the internet, right? Some of the internal services probably require e-commerce application access, but let's assume that it's going to be mostly internet-based e-commerce application access. The e-commerce servers or applications are going to be virtual servers. We're going to have some sort of physical load balancer that allows us to distribute the load across those e-commerce servers. And we want to make sure that we have a high level of tenant separation. Okay? That's the second to last bullet point. The last thing is that there's only one management authority. All right? So we don't have to have separate management planes or separate virtual management contexts. We're only going to have one administrator. All right? So that is our case study. All right? So if we look at kind of physically how this network is going to be built, the first thing we have to do is we have to isolate traffic that comes from the internet from the private traffic. All right? So we're going to create two VRFs for our layer 3 separation. All the traffic passes through a single physical firewall, and then at that physical firewall, we separate that traffic using our public and private contexts that we create. All right? So we would have to use a VDC on our data center switches, but we don't necessarily need to in this case. Why not? Because in this case, the infrastructure is managed by a single entity. That was the very last bullet point of our case study. So there's really no need for that management plane separation. All right, so we can just use basic VLANs to separate the layer 2 traffic. The private servers require their, you know, maybe a little communication between each other. All right, so we'll put them in a VLAN. E-commerce application servers are virtualized. They're going to be connected to an aggregation layer via a virtual switch. And then the VLAN segmentation of that virtual switch is going to allow us to only expose the web VLAN northbound traffic towards the aggregation layer. All the other communication between the application tier is kept inside of that virtualized network. All right. So we create a public VRF, we create a private VRF, which is built from these private and public contexts, and then we have a VLAN for our internal services and a VLAN for our public services. It's a pretty basic design. All right. Not much of a case study, quite frankly, but whatever. All right. Oops. Sorry about that. The last thing we'll talk about in this lesson is this concept of micro-segmentation with an overlay network. All right. Classic security models, they're hard to adapt to a multi-tier application requirement because well, why is that? Why is a classic security model hard to adapt to a multi-tier application environment? Because they're kind of ubiquitous, right? They don't really take into account multiple customers or multiple communication contexts. They take into account security as a whole, right? Securing the whole network from denial of service attacks, securing the whole network from zero-day attacks or malware attacks or whatever it is. We don't look at it from the perspective of each tenant, and then each tenant having the ability to control or manage their security within their own environment. All right. And generally speaking, in a classic security model, public and private services, they're not isolated from each other. They're not sealed from each other. But in the case of our environment, especially a multi-tenancy environment, internal business applications may need access to e-commerce and e-commerce applications, databases, or whatever. So there has to be potentially some application flows that need to extend outside of their predefined or configured private cloud tenancy, right? So we can create these application tiers that get distributed across layer 2 boundaries of our data center core. We kind of talked about overlay networks in the last lesson, right? And one of the ways that we can solve this problem of having this leakage, I guess, for lack of a better term, is to use this overlay networking, right? All right. So what we do is we take all those services that need direct communication, we put them into a common VXLAN. That's going to provide layer 2 connectivity independent of their physical location or their underlying layer 3 network, because we're now extending that network virtually as an overlay across the domain using this VXLAN configuration. Overlay networks allow services to communicate across layer 2 boundaries, but they can still have that communication isolation from other services because they still have their layer 3 distinction, right? Their physical connectivity. All right? Sorry? I look sleepy? Yeah. I don't know. Yeah, you do. Oh. Yeah, I'm okay. Do I sound sleepy? Your eyes are always closed. Oh, really? Oh, well. No, I'm not bored. It's all right. Public traffic. By creating this VXLAN, public traffic can be encapsulated in that VXLAN, and then as soon as it enters the data center, it gets sent to the load balancer, and in the case of the diagram here, we can see that goes through VXLAN 1000. The load balancer is then going to take that traffic and it's going to forward it through VXLAN 1010 to the public server. At the same time, the public server is a part of a different VXLAN, VXLAN 3000. That's going to be used by maybe your internal business applications to access your APIs of your e-commerce application, your databases, and so on. But it's still going to allow that to be isolated from the public traffic. So we can have all of these different overlays that allows this communication based on our communication needs. And that's the the huge benefit of implementing these VXLANs is to provide that layer 2 connectivity completely independent of the physical location or the underlying layer 3 network. It's pretty cool stuff. All right. So it was a short lesson this time. We talked about virtualizing of compute and storage resources, security, of course, and resource overutilization are some of our major concerns. Multi-tenancy essentially means logical isolation of shared virtual resources. We talked about, very briefly, device context. We talked about VDCs, which is basically just a virtual device context. We talked about VRF-Lite. The Lite means it's VRF without MPLS. A layer 2 network separation, and providing that layer 2 network separation through the use of VLANs, and then the overlay networks using our VXLAN. All right. So we'll wrap up this chapter and we'll move on to the next chapter.